Hello everyone, I'm Bob Mowzie. This Minecraft modding tutorial will show you how to create a model that can be animated using advanced techniques. We'll go over some important concepts and watch a time-lapse of this model's construction. I'm using Tabula version 5.1.0. You cannot use TechMe for this process as it does not support some crucial features that I will be using. This is not a comprehensive modeling tutorial as I will not be explaining the basic features of Tabula, nor will we be texturing this model. Leave any questions you have in the comments. The first concept that I'd like to go over is parenting. Now, parenting is a very important concept in animation as it connects all the boxes of your model together so that they can be moved in relation to one another and rigged properly. So for example, I'm looking at the Jurassic Craft Tyrannosaurus. On this model, which has been properly parented, I can rotate parts appropriately and accordingly to its anatomy and posing. I can bend its head down, bend that up, move its leg. Very, very important for animation that your model is parented properly so that the parts move in accordance with one another. As a counterexample, this model of Speed Stinger, created by Andreas, otherwise known as the Jurassic Alien, has not been parented. Before I show how this is a negative example, I'd like to say that this is still a gorgeous model. He's done a fantastic job and is very talented. But as you can see, if I attempt to do the same thing on this model that I was doing to the Tyrannosaurus, the parts don't move accordingly and things get left behind, not rotated according to its anatomy. This model cannot be animated because it has not been parented properly. Let's parent these two boxes. So before parenting, you can see that they rotate independently. One cannot control any rotation of the other one. They are completely disconnected. Let's fix that. Take one box in the model tree and drag it on top of the name of the other one. You can see it's now indented slightly, indicating that it has been parented to the other box. The interesting thing to note is that the box has moved. This is because child parts will actually move to be relative in position and rotation to their parents. If it were at position 0, 0 in the model, it would be somewhere around here. But now we have moved it to 0, 0 of this parent part, which is its rotation point right here. We can move it back very easily by just adjusting its position. Now, rotating this box will rotate both of them together. And this box can be rotated independently as well. The next concept that I'd like to go over is rotation points. Rotation points are indicated by small blue dots on each box that only appear when you've selected it. This box in the middle has a rotation point in its upper corner, which is the default location for a rotation point when you create a new box. The rotation point is the place at which the box will rotate around when you change any of its rotations. That point on the box will never move. This box has its rotation point in the center. Any rotation I apply to it will rotate it evenly across the entire volume of the box. This box has its rotation point slightly outside. Rotating it will once again move it around this point, sort of an orbit, since it is not attached. Rotation points represent the joints of your model and are very, very important for animation. This Lelanosaura is parented correctly, as you can see by the hierarchy in its model tree. However, I have edited the model to give it some incorrect rotation points. If you take a look at its leg, you'll see that the rotation points are correct. Now, there actually is an error. You can't see the rotation point of a child part when it's inside its parent part, but you can typically work around this. This point is where the leg will rotate around. It does not move. That's correct. However, if we look at the head and neck, you see that the rotation point is above its forehead. Rotating the head will disconnect it from the body and it will not obey its anatomy. This rotation point is above the body. You'll get some pretty ridiculous poses playing with its neck. Instead, rotation points need to be located at the joints of your model. Imagine lines connecting all the rotation points, forming a skeleton that will tell Minecraft how to handle the rotations of your model's pieces. The rotation point of this neck piece should be inside its parent piece right here so that it will pivot around the other neck piece. This rotation point should be right here inside its neck. So let's fix that. First, I'm going to adjust the offsets, which is the box's distance from its rotation point, to position the point where we want it inside the child box. Now I'm going to adjust its position to put it back where we want it. Now this piece will rotate around its neck properly. Let's fix the head really quickly. And there we go. Note that child parts will not be affected by the offset change, so you'll have to reposition these as well. Now, rotating the model's head, we'll pose it appropriately. The next concept that I'd like to look at is joint boxes. Each box rotates about its rotation point along an axis, one of three. An unparented box will rotate about its y-axis by turning left and right. Even if it has been rotated up or down, it will still rotate left and right properly. However, the axes of a child box actually become relative to its parent. Rotating this box about the y-axis will not make it go left or right, but instead rotate it side to side parallel with this box's x rotation. This can be useful sometimes as it can enable extra axes of rotation. However, if this were a head on a neck and you wanted your mob to be able to look left or right, this wouldn't really work. There is a solution though. Because the axis is in accordance to its parent part, we can add an additional box called a joint and attach it between our two boxes. Now we have to position it properly, of course. To reset this box's axes, the one thing we have to do first is counter rotate this box to this one's x rotation. So that's negative 45. Let's rotate this positive 45 and put this back to 0 so that this box now rotates left or right accordingly, even though it is still parented to this whole system. So now that we understand those three concepts, let's make a model. We're going to be making the masked tribesman model that you saw at the beginning of this video. This is a mob that will be implemented into Mowzie's mobs very soon. Let's start with the body. Something I should mention, it's very important that you do not give your boxes the same names. I see this mistake a lot, and this will not work even if you're not planning on animating your model. But for animation, it's actually very important to give your boxes descriptive names, because you will not be able to see what box you are using in the code. It's important to parent your piece before you position it. Otherwise, because of the relative positioning, you're going to have to position all of your boxes again, essentially making all of your previous work obsolete. And there you have it. The model is complete. Everything is parented properly. I can pose the arms, legs, all in accordance with how I want to animate this mob. Thanks for watching.